we've talked about inverse functions before, and we said that to figure out first and foremost if a function even has an inverse function, it has to pass the horizontal line test. So remember we said, if the function looks something like this, this passes the horizontal line test. This means it does have an inverse function. As opposed to, if your function looks something like this does not pass the horizontal line test, so no inverse function. So when you talk about trig functions then, sine, cosine, tangent, secant, cosecant, none of them will ever pass the horizontal line test because they just keep oscillating back and forth, back and forth. So if you draw a horizontal line through a sine graph, it'll cross infinite number of times. Well, what does that mean? Does that mean we're never going to be able to find an inverse function? No. We have found a loophole around it. And what we do is we restrict the function of the sine. Okay? So this is sine of x, and like I said, it has no hopes of ever passing the horizontal line test. However, if I only take a small portion of the graph, just that highlighted part now does pass the horizontal line test. Okay? So what we do is we restrict the domain. In the case of the sine, the domain is restricted between negative and positive pi over 2. Okay? When we do that, the range is still negative 1 to 1. So let's just think about this for a minute. For the sine function, right, we just restricted the domain to go between negative pi over 2 to pi over 2. And the range, we said, goes between negative 1 and 1. Okay? So now, if these are the domain and ranges for sine of x, then if I take inverse sine of x, what would the domain and range be? What would the domain be for inverse sine of x? So what happens to domain and range when you take an inverse function? They switch. Okay, so for the inverse sine, the domain will be negative 1 to 1, and the range will be negative to positive pi over 2. Okay? Okay. So what I just said is the sine doesn't pass the horizontal line test. In order for it to pass the horizontal line test, we're just going to take a small portion of it between negative pi over 2 to pi over 2. Okay? All right. So if we redraw that, just that part here, what we have is the inverse sine function. Okay? And this is how we write it, inverse sine of x, or arc sine of x. It's read as y equals the inverse sine of x. And if you draw it, so for the inverse sine of x, the domain is going to be what? Negative 1 to 1, and the range is going to be negative pi over 2 to pi over 2. Okay? So look, if we draw the inverse sine function, the domain goes between negative 1 and 1, and the range goes from negative pi over 2 to pi over 2. So we flipped it around. Okay? All right. Now, what does all this mean? So far, what I've been asking you for is, okay, you have sine of some angle pi over 3, and you tell me, okay, the answer is root 3 over 2. Okay? Now, I'm going to ask you in the opposite direction. So I'm going to say, all right, there is this mysterious angle, and if you take the sine of it, you get root 3 over 2. So what's the angle? And you tell me it's pi over 3. Okay, so now this answers the opposite question. So we say inverse sine of root 3 over 2 Okay, so what we're saying is, what is the angle, the sine of which is root 3 over 2? And the answer is pi over 3. Okay, so we're going in the opposite direction. All right, so let's write down let's just sketch a unit circle here. We said that we restricted the domain for the inverse sine function to go between negative pi over 2 to pi over 2. Now, I know that this is pi over 2. Negative pi over 2 means I go in this direction, it's here. So if the inverse sine goes from negative pi over 2 to pi over 2, then these are the regions where it exists. Okay? So from here to here, in these two quadrants only, does inverse sine of x exist. Okay? So inverse sine, I'm just explaining that what this means from going from negative pi over 2 to pi over 2 means if you go on the unit circle, negative pi over 2 is here, right? Because you go this way and that's negative pi over 2. This is positive pi over 2. The inverse sine lives between negative and positive pi over 2. Okay? All right. So here, let's do this problem. It asks you for the angle, the sine of which is root 2 over 2. So what's the one angle that gives you root 2 over 2 for the sine? Pi over 4. Okay? So the answer here is going to be pi over 4. Your answer, whatever angle you get, must either be in quadrant 1 or quadrant 4. Okay? Pi over 4 is in quadrant 1, so this works. Where are you going? Hall pass. Okay.
Can we only write it in green?
Yeah. All right. Inverse sine now of negative root 3 over 2. Okay? All right, so look. Which angle gives you root 3 over 2 for the sine? Pi over 3. It's the 60, which is the pi over 3, right? So, root 3 over 2 is the longer one. If you want the sine, that means you want the opposite angle, which is 60 or pi over 3. Okay? So, it's pi over 3. However, it tells you here that the sine is negative. In which quadrant between 1 and 4 is sine of x negative?
4.
Quadrant 4. So this must be in quadrant 4. Okay, so the way we write this then is negative pi over 3. It is, but the inverse sine only lives in these two quadrants.
Why is that?
Those exist. Those don't exist anymore. We restricted the domain.
Oh, that's right.
Okay? So the inverse sine only lives in these two quadrants. So when you're doing inverse sine, you cannot get an answer that's not in one of those quadrants. Okay? Even the positive angle, like 5 pi over 3, that doesn't work. Okay? All right, what about this one? Negative 2 pi. Yeah.
For the one before, does your answer have to be negative pi over 3, or could you take the long way?
No, that's what I'm saying.
You can't.
You can't. Okay, now look. Here we have inverse sine of negative 2 pi. Okay? What's the domain for the inverse sine? What did we say the domain was? What's the domain for negative 1 to 1, right? How much is negative 2 pi? Negative 2 pi is negative 6.28. What's pi equal to? Like when you're doing math, yes, just like that. Okay, so negative 2 pi is negative 6.28. The domain of sine is negative 1 to 1, so this is out of domain. So it doesn't work. We have never done a sine inverse problem yet. This is the first time we're doing it.
Yeah, I know, and it was the B and A.
Okay.
Does that work for them too?
Yes. But these were in the domain. Like this one has no solution. Okay?
So do we write out a domain or no solution?
Either. That's fine. Okay?
And it's no solution because it doesn't fit.
Yes. Okay? Alright. So that's inverse sine. Alright, so now let's go to inverse cosine. To make sure that inverse cosine passes the horizontal line test, we have to restrict the domain again. This time, we go between 0 and pi. Alright, you know how we went from negative pi over 2 to pi over 2 before? Now we go from 0 to pi. That means for the inverse cosine function, okay? Alright, so for cosine of x, we restrict the domain and we go from from 0 to pi. Okay? The range is always -1 to 1 for cosine. So what happens for the inverse cosine then? What is the domain and range for the inverse cosine? Right. Okay? Now, similarly, for inverse cosine of x, we're now going between 0 and pi. So let's see what quadrants those are. This is 0 and this is pi, so it's these two quadrants. Okay? So we have quadrant 1 and quadrant 2. All right? Now, look at this one. It says, find the angle, the cosine of which is 1. Now, you only get 1 or 0 for sine and cosine if you have quadrantal angles. Okay? So, where do we have a cosine of 1 here? Remember, cosine is the x-coordinate, right? So,
0.
it's either, right, so it's going to be at 0. So, here, right, but 360 doesn't work because the inverse cosine only goes from 0 to pi. Okay? So here this is x equals 1, y equals 0. So it's 0 radian or 0 degrees. Okay? All right, look at this one. -√3 over 2. Okay, so what's the angle, the cosine of which gives you √3 over 2? It's going to be pi over 6, right? Pi over 6. However, okay, so what's the, well, okay, so pi over 6. Remember, this is what we were doing with the unit circle and what you had to know for the test? Okay, so same thing. So if you have cosine of pi over 6, right, you know that if pi over 6 is here, that's like 30 degrees. It faces the small side of 1 over 2. And this is √3 over 2. So the cosine of pi over 6 is √3 over 2. Now I'm going backwards. What's the angle, the cosine of which is √3 over 2? Well, it's pi over 6. Okay? All right, so pi over 6, except the cosine is negative. Meaning, it's in quadrant number what? 2. Right? Remember, it can only live in 1 or 2. It's positive in 1. Okay, so cosine only lives here. Okay. It's positive here, it's negative there. Okay? So if it's negative, it must be in this quadrant. Okay? So now, how do you get pi over 6 in that quadrant? Pi over 6 in that quadrant will look like this. Yes. You want that one, which is 5 pi over 6. Okay? Just short of a pi. No. Yeah. No, the inverse is you're finding an angle But in this case, because we want to move it to another quadrant, then you find the balance. Okay? Well, the angle isn't going to be negative, right? The angle just goes from 0 to pi for this, but you want one where the cosine is negative, and that's quadrant number 2.
Wait, how are we supposed to know that it's 5 pi over 6?
Okay, so we decided on pi over 6 before, right? Okay, so in this quadrant, what angle has a reference angle of pi over 6? 5 pi over 6. Okay? All right. In this one, you're looking for inverse cosine of negative 2, but again, it's out of the domain. So this is no solution. I'm going to do a lot more. Let me teach the entirety of the lesson. We're going to do so much of this. Okay, restricted tangent function. So for the tangent to pass the horizontal line test, it's easy. We just take one of the arms, and it's going to go between negative pi over 2 to pi over 2. So again, right, if I take the unit circle, and if I go between negative pi over 2 to pi over 2, one more time, just like the sine, it's between quadrant 1 and quadrant 4. Okay? So whatever angle I get must either be in quadrant 1 or quadrant 2. Tangent is positive here and negative here. So if I'm looking for a negative tangent, it's going to be in quadrant 4. If I'm looking for a positive tangent, in quadrant 1. All right, so let's do this one. Arc tangent of 1. What angle gives you a tangent of 1? Tangent of which angle is always 1? 45 degree. Tangent of a 45 degree is always 1, remember?
Oh, yeah, because it's pi root 2 over 2.
Right, so this is going to be pi over 4. And since this is positive, it's going to be in quadrant 1. Okay? Okay, so what's tangent of pi over 4? 1. Okay? All right. Yes. Okay. The arc tangent, it's positive again, so it's going to be in quadrant 1. Okay, now, which angle has a tangent of root 3 over 3? 30 degrees, pi over 6, is that right? Yes? You are sure? Okay, so this is what pi over 6 looks like, right? And if I want the tangent of this, it's opposite over adjacent. This is 1 over root 3. This is root 3 over 3, so it's pi over 6. Okay? All right. If you're still not comfortable with this, draw one of the triangles. Just draw a triangle one time, one for the 30, 60, 90, and one for the 45, and just keep referring to it all the time. Okay. This chart just basically summarizes everything we just talked about. There is another chart at the end of the lesson which we'll come to, and it's a better chart, I think. Okay, I'm going to come back to the graphing. Let me do this first. This chart, this is what I was talking about. You should know this chart pretty well, very well, because it tells you the domain of each function. It tells you the interval of each one. This is very important. And what's more is it tells you the quadrants where each of them live. Okay? So for the sine, it's going to be quadrants 1 and 4. 1 and 2 for the cosine, and 1 and 4 for the tangent. Okay? That's where all of them live. Okay, now, let's do some really good ones. Now, if you have the sine of the arc sine of something, it's just like having a square root and a square. We're going to come back to it later. if you have a sine and an arc sine, it's like having the square and the square root. They cancel each other out. Okay? So this goes away and you just have a half. Okay? Now, that is a fun one. In the case of this one, okay, you have the inverse cosine of the inverse of the cosine of whatever. It goes away again, 5 pi over 2. Okay? If you ever have those on a final or on a test or on a whatever, those are the ones where you win points. Okay? And it shouldn't take you more than like a fraction of a second to do. Now, here's this one. Nope, not the same thing. Because how much is this? Negative 5 pi over 2. Does it exist? Does tangent of negative 5 pi over 2 exist? What's tangent of negative 5 pi over 2? So this is tangent. What's negative 5 pi over 2? This is negative 2.5 pi. Where is that? Negative 2.5 pi is here. This is x equals 0, y equals minus 1. What's the tangent? Undefined. So this doesn't work. Okay, so watch out for those. Trick question. All right, now. Okay. We're ready? All right. Now, here we have the inverse cosine of 4 over 5. And you have a sine outside. Okay, so sine of inverse cosine of 4 over 5. For once now, these don't go away. What you're going to do is you're going to start from the inner function. Okay? Start with inner function. All right, now, the cosine is positive here, right? So 4 over 5 is positive. Where did inverse cosine live? In what two quadrants does inverse cosine live? The first and second. But if 4 over 5 is positive, then which quadrant do I want? The first one. Okay? Just set that aside for a minute. Now, you start with the inner function and you draw a triangle. This tells me I have an angle theta, the cosine of which is 4 over 5. That means the adjacent over the hypotenuse is 4 over 5. Okay? Now, is there any way I can find the other missing side? It's 3. Okay, because 3, 4, 5 is a right triangle. Now, second step is work with the outside function. Oops, outside function. Now you want sine of theta. Well, what's sine of theta here? 3 over 5. That's it. Okay? And because I'm in quadrant 1, sine of theta must be positive. In quadrant 1. Okay? So if we were supposed to be in quadrant 4, you would have had negative 3 over 5. All right, one more. These are even more fun. All right. Oh, okay. All right, so cosine of the arc sine of x. Okay? So here's what we do. We start with the inner function and draw a triangle. This is theta. The sine of it is x over 1, meaning opposite over hypotenuse is x over 1. Yes? So how do I find that missing side? This is, suppose, what is this one? It's the square root of 1 minus x squared. Okay? Quadratic form, Pythagorean theorem. Okay? Now, how do I find the cosine of this? Cosine of theta is adjacent over hypotenuse over 1. So that's all. Okay? Let me do one more. Look at this one. Start with the inner function. I have a function, I have a angle theta, the cosine of which is x. So this is x and this is 1. Okay? Now let's find this one. Let me go through the process. So let's call this b. X squared plus b squared is equal to 1 squared. B squared is equal to 1 minus x squared. B is the square root of 1 minus x squared. Okay? Now, how do I find the tangent of this? What's tangent of theta? Right. The square root of 1 minus x squared over x. Okay? Right, I called this b first, and so I said x squared plus b squared equals 1 squared. Here. Oh, for this one you mean? No. I found this side by doing the Pythagorean theorem. Okay, and then I wanted to find the tangent of it. So it's that over that. Okay, so the inverse cosine of this is x, right? That means I have an angle theta. The cosine is x. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse is x over 1, x. Okay? All right, how about some graphing? You guys ready for some graphing? I am. Okay. So we're sketching the graph of arc sine 3x. There are different ways to do this. I'm going to do it in a way that I found was successful last year and the year before that I taught this. All right, so what is the domain of the inverse sine of x? Negative 1 to 1. And what's the range? Right. Now, the domain of the sine of x is negative 1 to 1, right? But what about for sine 3x, inverse sine 3x? What you're going to do is this. Negative 1 less than or equal to 3x less than or equal to 1. We've seen this before, right? Yes. So now negative 1 over 3 less than or equal to x less than or equal to 1 over 3 is my new domain. Okay? That means my graph is going to go between negative 1 over 3 to 1 over 3. Okay? Now, here's the best way that I found to do this. This is y equals arc sine of 3x. You could also write it as inverse sine of 3x. I'm just, writing it in different notation. I haven't changed a thing. Okay? Now, what I'm going to do is take the sine of both sides. Why? Because I can do that. Okay? No, I'm taking sine of y, sine of inverse sine. Now when I do that, here I have sine of y equals, what's sine of inverse sine of something? Just something, 3x. Okay? Yes, now we're going to solve for x. So now 1 over 3 sine of y is equal to x. Okay? Oh, it's slow. Okay. 3x. Here, I took a sine of both sides. Okay, now what I'm going to do is this. You know how we always pick points x and y? I'm going to do the same, except, okay, I'm going to pick my points for y. Not x, but y. Okay? So I'm going to choose points for y. And what are my points going to be for y? It's going to be this range. Okay, so we're going to go from negative pi over 2 to pi over 2. Okay? What's the halfway point between negative and positive pi over 2? 0. Are you like 3 steps ahead of me? It seems like. All right, so what's the halfway point here? Pi over 4 and negative pi over 4. Okay? Now, we just solved and we got that x is equal to 1 over 3 sine y. Okay? So is there a way we can plug these in here? I sure hope so. Let's see. So here, we get 1 over 3 sine of, what's y? Negative pi over 2. Okay? So how much is that? What's sine of negative pi over 2? Here, sine of negative pi over 2, negative 1. So this is going to be negative 1 over 3. Okay? Let's do it again. 1 over 3 sine of negative pi over 4. The pi over 4s always get a what? Root 2 over 2, right? So this is going to be negative root 2 over 2. So 1 over 3 times negative root 2 over 2. What about this one? 1 over 3 sine of 0. What's sine of 0? 0. 1 over 3 sine of root 2 over 2. How much is that? Root 2 over 6. 1, Danielle's helping me. 1 over 3 sine of what? Pi over 2. What's sine of pi over 2? No. Huh? Here? Or here?
Wait, so you can't multiply it?
Sine of, oh, that should be sine of pi over 4. That should be sine of pi over 4, which is root 2 over 2. Right, so, okay, so what's sine of pi over 4? Root 2 over 2. But it's 1 over 3 times that. Yeah. So it's 1 over 3 sine of pi over 4, which is 1 over 3 times sine of pi over 4 is root 2 over 2. So that gives you root 2 over 6. All right? Makes sense? This is 1 over, yeah. Negative root 2 over 6, positive root 2 over 6. Okay? So now, when x is 1 over 3, y is, what? Negative pi over 2. Okay? Is it? That's what I'm looking at. Oh yeah, it is negative 1 over 3. Here. That's what I was looking at. So here. Alright, when x is 0, y is 0. When x is 1 over 3, y is pi over 2. Okay? And these are the middle points here. So it looks like this. It's a curve. It's a curvy line. Okay? Okay, so for the tangent, what is the domain for the inverse tangent? Right, and what is the range? Right. So sometimes it doesn't come out, you know, like when anyways, I don't know. All right. Yes, I know. No, because what does tangent have? Okay. So this is y equals inverse tangent of x over 2. You take the tangent of both sides, so you get that tangent of y equals x over 2. Multiply both sides by 2. So you get that x equals what is x equal to? 2 tangent of y. Do you guys mind if I write that here? Okay? Because I want to use the space for the chart. I should have thought ahead before. All right. So now I have my x and y. All right. And here I want to pick the same values, negative pi over 2 to pi over 2. Right? This is 0. This is negative pi over 4. This is positive pi over 4. And here we have our pi over 2. All right, so x is equal to 2 tangent y. So x is equal to 2 tangent negative pi over 2. What's tangent at negative pi over 2? What does tangent have at pi over 2 and negative pi over 2? Okay, so for the regular tangent, where is the asymptote for the regular tangent? At negative pi over 2 and pi over 2. So this is undefined. Okay? All right, so here, x equals 2 tangent negative pi over 4. What's the tangent at negative pi over 4? Negative 1. So this is 2 times negative 1, negative 2. X equals 2 tangent of 0. What's tangent of 0? 0. X equals 2 tangent of pi over 4. Positive 2. And here, x equals 2 tangent of pi over 2. Undefined. Yes. Yes. So at x equals, okay, so at y equals pi over 2 and negative pi over 2. Okay, so look at this one. Y equals negative pi over 2 is here. X is undefined. There is no x because here we have an asymptote. Okay? What do you mean? Geez, if only this was a democracy. So when y equals negative pi over 4, x is equal to negative 2 here. If y equals 0, x is 0. When y equals pi over 4, x is equal to 2. And at the pi over 2, x is undefined because we have an asymptote. And here. All right? Homework due tomorrow. Huh? The word problem? I'll do the word problem tomorrow, but it shouldn't really affect.